Greetings, M squared here, and we are going to talk about exponential functions. We're going to talk about the features of an exponential function. So there's a couple features we need to be aware of. This initial value and this constant ratio. So an exponential function always has an x as an exponent. It always has some base number that it's being multiplied over and over and over again, depending on what that x value is. And then an initial value. Now, if you don't see an initial value, it means it's 1. Like if you just had y equals 5 to the x, that's still an exponential function. It just means the initial value is 1. So you might not always see that. Today we will, but just so you know. So just like the other functions we learned about, absolute value functions and quadratic functions, where we shifted them left and right and up and down, we're not really going to get into it, but I do want you to know it could happen. There could be a number here which would shift it left or right, and a number here which would shift the graph up or down. Also, it can look like this. Now you might think that doesn't look like an exponential function. This t is our variable regards to time. This is what we use in banking, and we'll get into that later in a week or two. But this is a function, an exponential function that is used for interest in an account. So this would be the principal value, which is what you start with. This would be the ending value. And this would be the rate or the percent of interest you're getting. This would be the number of times it's compounded in a year. And this t is the number of years. And again, we will talk about that later. So today our goal is just, can you find the initial value in an exponential function? And can you find the constant ratio, the thing that's being multiplied over and over and over again? So when we look at our function, this is our a value. So that's our initial value. That's the starting amount. That means when x is 0, that's my initial amount. We're going to fill in this table. But if I put a 0 right there, I'm hoping you remember that when we take something to the 0 power, what you get. So I'm waiting for you to think about it. What do you get when you take a number to the 0 power? 2 to the 0, 5 to the 0. Hopefully you said 1. So I know that 1/4 to the 0 power, that means I'm finding f of 0, right? I'm going to find this value first. F of 0 is 1. And 64 times 1 is 64. So a couple things about the initial value. If you're looking at an equation, the initial value is right here. It doesn't have an exponent. It's multiplied by the constant ratio that is raised to the exponent. If you're looking at a table, it's always the y-intercept, or when x is 0, that is your initial value. So if I give you a table and I say, hey, what's the initial value? You'd always look for the 0x, the x equals 0, and know that your y-intercept is your initial value. Your constant ratio is the number that's being multiplied by each y value to get the next y value. So if I put a -2 in here, okay, so I'm going to find f of -2. So I'm going to take 64 times 1/4 to the -2. Hopefully you remember what happens when you take a number to a negative something. The negative tells you to flip it. Remember, negative exponents, they like to move it. So we would actually flip this around. So we'd have 64 times 4 squared. That's what our -2 tells us. That we're still gonna square this, but we're gonna flip it over. So I flipped it, now I'm gonna square it. So 64 times 16. Now 64 times 16, I'm going to get out my calculator because I'm not sure what that is in my head. It's 1024. Okay, 64 times 16, f of -2 is 1024. Now I'm going to find f of -1. So I'm going to say 64 times 1/4 to the -1. So the negative tells me to flip it and then take it to the first power. It's just going to be 64 times 4. What is 64 times 4? It is 256. Now you'll notice what's happening each time. Each time from this y value, I'm multiplying by 1/4. I'm multiplying by 1/4. So to get to this value, I'm multiplying by 1/4. That would be 16. Or to get to this value, I multiply by 1/4. That would be 4. But just so you can see what we do if we didn't know that constant ratio if we were just using our x values and plugging that back in and making our table. We would say 64 times 1/4 squared. 1/4 squared is 1/16. So it's actually like 64 divided by 16, which is 4. So I wanted to show you how you would actually create a table with an exponential function before I start giving you tables and asking you to write the equation. So again, where's the initial value? It's right here, the y-intercept. What is my constant ratio? It's whatever the number is that I would take this value, would multiply this value by to get this value. Okay, so we're going to figure that out just by looking at a table. So 5 times what equals 10? Well, the opposite of multiplication is division. So if you don't know that, you could go backwards, right? 5 times what equals 10? 2. But they said 10 divided by 5 is 2. What would I multiply this by to get that? Or what this divided by what? These two divided by each other. What do you get? You get 2. 20 divided by 10 is 2. 40 divided by 20 is 2. 80 divided by 40 is 2. So 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. Whatever I'm multiplying by to get from here to the next one, x is increasing. What am I multiplying by? That is the constant ratio. I'm hoping someone sees the initial value. Remember what we look at for the initial value? We look right there, right? That's our y-intercept. So the initial value is 4, the constant ratio is 2. If we have those two things, we should be able to write our function. F of x equals the initial value times the constant ratio to the x power. Okay, let's try another one. So what would you multiply 2 by to get to 6? 3. Is this times 3? Yes. Times 3, times 3, times 3. Once you've established, yes, it's all times 3, then we know that our constant ratio is 3. It's going up. What's our initial amount? It's whatever the y-intercept is. That's 2. So what's the function? Well, we can write the function like this. Initial value times the constant ratio to that power. Okay, let's try another one. You'll notice this time we're not going up, we're going down, but I still want to know what would I multiply 12 by to get to 6. Hopefully you know that's 1/2. What would I multiply 6 by to get to 3? Again, 1/2. What would I multiply 3 by to get this? 3/2. 3/2 times 1/2 is also 3/4. So my constant ratio is 1/2. Okay, what's my initial value? Well, it's the y-intercept, and the y-intercept is right there. When x is 0, it's 3. So how could I write the function for this table? I would say f of x equals 3 times 1/2 to the x. Now these two are asking, hey, is this an exponential function? How can I tell? Well, what I do is I say, well, what would I multiply this one to get to this? And if it's the same for each y value going down the line, then it's an exponential function. So what would I multiply 6 by to get to 3? Well, we just did that up there, I think, 1/2. Is 3 times 1/2 0? No, it's not. So this is not an exponential function, not exponential. But just for fun, let's see what it would be. What's happening each time? Subtract 3, subtract 3, subtract 3, subtract 3. That's a subtracting the same amount every time. That is always a linear function. And in a linear function, we look for the y-intercept. This is our slope, and that would actually be y equals 3x plus 3. Let's see if it works. Let's put a 3 in and see if it works. So if I put a 3 right here, what's 3 times 3? 9, and that was negative. So negative 9 plus 3, that is negative 6. So I can check it that way too, by plugging it in. Okay, does this one represent an exponential function? Well, sometimes decimals can be kind of tricky, right? So let's say you don't know what 3/4 times what would get you 3. So 3 times what gets you 12? Well, that would be times 4. And then you ask yourself, does 12 times 4 get me 48? Yeah, it does. And then if you don't know, you could say what's 48 times, what was that, 4? What's 48 times 4? 192. Well, what do you know? It's right there too. And so you could say, what's 0.75 times 4? And it's 3. So now we know that our initial value, right, is 3, and our constant ratio is 4. So yes, this is exponential. All right, so in your homework tonight, you're going to have to find the constant ratio. You're going to have to find the initial value. And you're going to have to know whether it's exponential or not. So good luck with that. M squared signing out.